Okay, welcome to part 2 of the OSPF configuration example. So we have a topology here, very similar to what we saw in the first video. In this video, we're going to actually configure this topology. We will be using a SRX device. Actually, we'll be using a single SRX device and using virtual routing instances to create what are in essence virtual routers, and that is the topology. So instead of having, what do we see here? 5 different routers, physical routers in my hardware here. I have one device, and I've defined 5 different routers logically. So it's very neat. I'm using a Juniper SRX 100 to do this configuration. So if you're interested in being able to start playing around with this type of thing, really check out those SRX devices. They're really, really slick in terms of their capabilities. So, but let's get to what we're going to do here. So, to start off, let me talk about the topology. Right, we have our a backbone area here. All right, that's area 0 here, and all the traffic has to transit the backbone area. Routers that border a backbone that border area 0 and another area, of course, are ABRs, right? So we see 2 ABRs here, and then we see another. So these are, let's just indicate that, right? ABR, right there, area border router, right there, and then of course, right here, we have an ASBR, right, which is an autonomous system border router, because it's bringing in these static routes from this external router, external to the OSPF network. So this is an ASBR. So to start with, this is just for clarification. I've already configured these stub areas, right? So we have this. I'm sorry, I've already configured these areas. What we will do is we will turn this guy into a stub area to begin with. All right, we'll talk about what that means, and then we'll do some things over here. But for right now, let's just talk really quick about what we're going to see when we take a look at this particular area these particular areas over here. So, so remember, areas are all about being more efficient with the LSAs and the flooding of the LSAs in the network. So here in the backbone area, we're going to see LSAs 1, 2, 3, 4, and 5, right? 1, 2, and 3, right? We have routers here. We're using, this is an Ethernet topology, so the 2s will come in because these are going to define themselves as designated routers and backup designated routers. The 3s are here because there's a network that's identified here. I'm sorry, the 3s are coming in because we're getting summaries from other networks, right? From VR 316 and VR 313, right? And then 4s and 5s are external, so they're coming in from area 2 over here because we have an ASBR, right? So those are all the LSAs that we'll see in the backbone, and there's really not much we can do to make the backbone more efficient. But what we can do is make, for example, this area over here more efficient. So across this ASBR, we're going to see 3 LSAs come over, and the 3s are going to be coming from the 3s from the other networks, for example, 313. Or actually this segment right here, the 10.0.2.0/30 network will be a 3 that already exists. And then we'll also see that these 1s and 2s also turn into LSA 3s in this network. And this is before we really start making things really efficient. Then we'll also see, again, before we've done anything, the 4 LSAs come over and the 5 LSAs come over. And remember, the 5 LSAs come over unchanged, right? The 3s are specific to the areas that they're identified in, as are the 1s and 2s. The 4s are also specific to the areas that they're identified in, right? But the 5s, they get unchanged across the entire autonomous system. All right, so that's what we'll see initially. Coming over this way, because we just have the 1 network, we'll just see the 3. They're inside this network. Before we do anything, we'll see 1, 2, 3, 4, and 5. Okay, and inside this network, before we do anything, we'll see 1, 2, 3. I don't think we'll see any 4s because even though this is an ASBR, it's inside this area, so it knows how to reach what's happening inside this area. But I do believe we're going to see a 5, which is still this ASBR's external routes. That's what we should be seeing here. So we'll verify that in the configuration. And then coming across here, again, we'll see some 3s going across here. Since we don't have any ASBRs in either of these, we won't see any 4s or 5s. And coming across here, we're going to see 3, 4, because we have the ASBR, and 5, right? So that's what we'll see before we do any configuration. So you can see there's a lot of LSAs flooding across the entire network here. So the first thing we're going to do is we're going to turn this guy into a stub area over here. Okay. So once we turn him into a stub area, the first things that happen is we lose these LSAs from coming, the 4s and 5s from coming, and they disappear off the area there. Okay, so that's the first thing that happens. So we immediately start seeing some reduction in what's happening from that from this standpoint. Okay, and that's nice, right? We get to see those go away, and we have some efficiencies there. But if we want it to be even more efficient, we would then turn this into what's called a totally stubby area, right? And by making a totally stubby area, what we do is we get rid of all of these 3s that are generated here, and instead of a 3, whoops, let me finish erasing that. So instead of a whole bunch of 3s from the entire network, what we're going to get is a single 3, which is really a default route. That's really all it is. It's just a default route that talks about how to get to the rest of the network. It'll be a type 3. Okay, so let's put 3 in here. It'll be a type 3, but it'll just define the default route, how to get to the rest of the network. So that's by creating a totally stubby area. And we're going to do this through configuration. All right, so it's not going to be something we do by defining like a static route. It's going to be done through configuration, that it'll inject that static route. So once we've done that, we'll come over here and we will then turn this side into a not-so-stubby area. Okay, and a not-so-stubby area has all the attributes of a stub area. Okay, so by turning it to a stub area, one of the things that happens is we lose these 5s. Okay, so they are no longer allowed. I think a good way to look at it is they're considered to be illegal. But we still need to find a way to put that external route in there, so we have this 7 LSA that gets created. Now, the funny thing is that the 5s don't go away, because when they cross the area border router, the 7s turn into 5s, and so that 5 that's here will stay here, and the 4 that's here will stay here as well, because it'll talk about how to get to that ASBR. Okay. One of the other things that we can do is, if we decide to create what's called a totally not-so-stubby area, then we will create a default route here, right? And again, it'll be that generic type 3 LSA, and in doing that, we've gotten rid of the 3s that get broadcast this way. So we've made it even more simplified over here. So that's probably the most we could do to make this an efficient topology from the standpoint of what we're seeing. So so that's what we're going to go ahead and do here in the configuration side. And if you have questions for me on what I did, or how I did it, or why I did the things, please feel free to comment. But let's go to the configuration. Okay, so we're sitting here on my SRX100 device. Now, just to be clear, this topology that you see is all encompassed within this SRX100. So I've created these logical tunnels, and there's a lot of information on how to create logical tunnels on the Juniper website. But I've created these logical tunnel interfaces, and once I've created the interfaces, then I've actually gone in and these are some of the policies. Here you see the routing instances that I've created for this particular scenario. So we'll go into each one in depth, but I wanted to show you that this whole configuration will take place on a single Juniper device. This is one of the really nice features of Juniper for a SRX100, which you can get on eBay for probably around $100, $150 if you really pay attention. This is some pretty neat technology. So let's start. Top show routing instant. Whoops. What did I do wrong? Top show routing instances. Let's start with VR. Let's start with our external device just to kind of go around the loop here. So you can see how this guy is configured. We have our first interface here. Actually, see there's a physical interface. If we were to follow this topology through, it actually would be connected to another SRX device that I have. But we're not going to be using this this particular interface for this topology. So we're just going to be focused on this guy right here, on the logical tunnel. It's the first one. Notice its routing options are set up as static, so it has a default route that points back into the SRX loop, and then this is its router ID. So the router ID is always a combination of the name, which is VR311. So you see VR and then network 3 IP11 there. All right. So let's just real quick kind of go around the hoop here. Take a look at VR313. Here we see it again. It's a virtual router. We have the logical tunnel 0.2 and the 0.3. We also have a loopback assigned for this one. In addition, we have an aggregate route defined here, although I don't think we're going to use the aggregate route. This is probably left over from my BGP demonstration that I was doing. And then we have the router ID. Here we begin to see some protocols assigned to it, and we see that the interfaces, and we see that both 3 and 2 are assigned to Area 2, which is indeed the case. It's completely contained within the Area 2 interface. Let's take a look now at VR14, and we'll see that we have our virtual router. We have 3, 4. Again, logical tunnel 6 is left over from previous lab. We're actually not going to use that. It's unneeded for our particular topology, so we'll just disregard it for the time being. In fact, I'll probably go ahead and delete it here when we take a break in the video. We see the router ID, and again, we see the OSPF options. This time, this is an area border router, right? We have interface 5. 0.5 is on area 0, and interface 0.6. I'm sorry, 0.4 is in area 2. All right, so let's take a look at the next one. And with this one, again, we see the logical tunnels. OSPF area 0, right? It's the interface 0.8, so that matches. And we see area 1 here for the first time. And then let's go to, I believe it is 16. And there we see the last router. In this case, we just have the single logical tunnel 10. It's a part of area 1. So that is the fundamental setup here. If we were to do a run show OSPF neighbor, whoops. Okay, so now you see the first consideration when you're using the Juniper routing instances. This command would run underneath the master routing table, and there's multiple routing tables inside Juniper. So it says OSPF is not running because I did not give it an instance. So let's make sure I select the right instance, and we will start this time working the other way from right to left. So we'll say instance VR316. So we'll see that, sure enough, the neighbor of 316, we see the IP address and the router ID. So it's 315 is the router ID. So let's just move our way across here. 315 now is an area border router, so we should see 2, and indeed we do. We see 316, which we just left, and 314. We see the IP addresses and the interfaces are talking. We go to 313. Again, this is an 313 is completely in apparently area 2 here, as we see from the IP address. The middle, the third octet here represents what area you're in. And then we see that it has 314 as its neighbor. And we go to 311 here. And 311 is a external router, and we're not running OSPF on that external router. All right, what did I get? 313. Oh, I missed 314. That's what I missed. Let's just take a look at 314 real quick here. There we go. There's our other area border router, straddling area 0 and area 2. And we see that it has created a full adjacency with 315 and 313. All right, so let's start creating our stub area. Okay, so before we create our stub areas, let's take a look at our LSA database. So let's do a run show OSPF database, and let's do instance. Let's take a look at our virtual router 316 first. We'll go from right to left. And what do we see? So we see the type 1 LSAs for the 3.15 and 3.16 routers, right? Those are the 316 is the one we're on. 315 is the area border router. We see the network summary or the type 2 LSA for the one network, since it's a shared network and we have designated routers here. Notice the asterisks also indicate the router that we're currently on, right? We're on, well, in this case we asked for 316, right? So we see the type 1 for 316 and the network for 316. We also see type 3 or summary routes for the 0 network and summary routes for the 2 network, or area 0 and area 2. And then we also see the ASBR indicated here. And finally, we have our external route for the 10 network, and we're going to get to that. So this is our type 5, get to that through the 313 virtual device. So this is our type 5. And remember, when we create a type 5, you're going to create the type 4 to go along with it. So if I want to get to the 10 network, I'm going to go to the ASBR. That'll tell me how to get there. So that's what we see. So once we create a stub area for area 1 here, we should lose this guy and this guy, but we should retain everything else. So let's go through and let's configure area 1 as a stub area. So let's go into that hierarchy. Top, edit, routing, instance, VR316. Let's just take a look at what's happening inside there. Okay, so let's configure the stub option, the stub knob on the area. So we're going to do a set protocols, OSPF Area 1, which I can do because I have leading zeros, so that's kind of a shortcut there. Stub. Pretty simple there. And let's do a show. Take a look at that. There's our stub command. So now let's do the same thing for... Now we have to add that stub command for every interface in that area. So now we've switched to the VR15, and we can run the same command. And so let's do a show command, and there we go. We have, for area 1, we have stub on both of those. Let's go ahead and commit. So because we're running virtual instances on a single device, only one commit is necessary. Obviously, if these were different routers, we would need to do a commit for the 316 router and a separate commit for the 315 router, but since they're both on the same device, one commit will suffice. So we should be coming back up here, and there we go. Let's take a look at our. Well, let's start by taking a look at our neighbor, or our adjacencies. So we'll do run show OSPF neighbor, and let's do it from instance. Let's do VR315. So let's take a look at the. Oh, look at that. This is our area border router, and notice that this is our area 1 adjacency. We have a two-way state. So looks like there's been some additional communication that's happened. They're recreating their state. Let's see if it's going to get hung up, or nope, there it goes. Now we're in a full adjacency. So we've created a new LSA. We've created a new adjacency here, and some some new database information that now exists. So let's take a look at that database. And let's see if we can find that command real quick. Probably could have just typed it out. So let's take a look at the VR316 database. And let's see what we have here. So we still have our external or type 5. We seem to have lost our type 4. I'm interested in why we even see this guy anymore. Let's take a look at the route table. Run show. Let's see. Run show route. Let's do VR315 again. Oh, that's what the. Oh no, I did 316. Let's do 316. Show route 31. Oops, sorry. Route table VR316. There we go. All right. So we have our stub information. Notice we are missing our 10 network, so it's not showing up in here. It's as to why the external route was showing up in there. It might be an age issue. It might need to age out. Maybe if I clear my database and then recreate it, it would flush this information out. Oops. Let's see if we can clear OSPF. We can clear OSPF database instance VR316. That worked. Now let's take another look at our database. There we go. So now that we've cleared it, we can indeed see that that external route is gone, or the external entry rather is gone. And when we take a look at our route table, we see that we only see summary routes as well. Okay. Okay, now to create our totally stubby area, remember that would get rid of any summary routes, any type 3 LSAs. We have to make some configuration changes on the area border router. In Juniper, you do this on the ABR. So let's go ahead and let's do a show here just one more time. Remind ourselves what we're doing here. And let's do a set protocols OSPF Area 1 stub default metric 10. This will create a default route, and this will restrict the summaries. So let's do a commit. Okay, so now let's go ahead and take a look at what's happening, and we're going to go and take a look at our VR316. So let's do that by doing a run show. Let's take a look at our route table. Show route table VR316. Let's see what we got here. Look at that. Remember, in the previous route table, if we scroll up here, I think this is it right here. Yeah, route table 316. We see that we have a summary route for the 2 network and a summary route for the 1 network. If we look at this guy now, interestingly, we see that we still have our static default route, but we also now have an OSPF default route. We also no longer have any summary routes. These are all direct attached routes, right? We did not see this OSPF. Let's just take a look at that one more time. Yeah, we only saw the static default route here. And so now we have an OSPF default route. Okay, so we've configured our totally stubby area. Okay, so we need to switch to the other side of our topology, and now we're going to be dealing with the routers VR313 and 314. So let's start by getting over there. So top, edit, routing, instances. VR, let's do 313 first. Let's just take a look to remind us what we have going on over here. Now remember, this export policy exports our static route into OSPF, and it displays it as a external route with the routing preference of 150. To configure the Nssa area, you have to configure it on each interface that's a part of the area. So let's go ahead and run that command now. So let's see, we're going to do a set, protocols, OSPF, and we're going to pick our area. It's going to be area 2 this time, and SSA. That should be it for this interface. And now let's switch to, excuse me, 314. Let's take a look at what's happening here, and let's configure it on, actually we should be able to just do an up arrow and do the same thing. Show, there we go. Let's do a commit. Okay, so if this worked, we should be able to do a run, show OSPF database, and let's do some comparisons here. First, we're going to look at VR313. Oops, I got to have instance in there. Instance VR313. So this is our ASBR, and we see there's a NSSA indicator. Let's now go, that is actually the indication of a type 7 LSA, right? So that NSSA indicator. So now let's take a look at our area border router. Let's just kind of work across here. So if you see here, sure enough, on the area 2, we see our type 7, as well as some externals here. Area 0, we do not see those. So let's go into our VR, our other area border router. Just kind of working our way across the topology. And we still have, in area 1, we still have our external route, as well as, well, we see them here because we're on the area border router. We should not see them once we go into the ASBR. We have our network routes, so let's take a look at our database inside 16. And there we go, we don't see our external routes. The only network route we see is for our own network. We don't have any summary routes except for this default route, which I guess technically is a summary route. So there you go. We've actually, we should look at the routing table before we finish up here. So let's look at our routing tables. Run show route table. Let's just kind of go around the horn again. VR313. So this is our autonomous system border area router, and we see our 10 network listed there, as well as summary routes for the 2 and the 1. Let's take a look at our area border router. Should be pretty similar. Indeed, we see our 10 and our 2 and our 1. Our 315 will be similar, so let's take a look at 316. Again, should be pretty sparse. Sure enough, we have our default route that we dynamically configured, right? And our 1 network, which is the network we're directly attached to, and that's it. This is the multicast for OSPF as well, so you'll see those on all the routes that have OSPF configured. So there you go. We through the course of this video series, we talked about how LSAs work and how to restrict them and shrink the size of our LSA database and our route tables as appropriate. So we looked at normal areas, compared them to stub areas, totally stubby areas, and not so stubby areas, and went through the configuration options. These were just an introductory look at the various options available. There's a lot more to configuring the options inside stub areas, and definitely do some more research if you want to implement these in a production environment, specifically in Juniper, because there are some really specific things you want to pay attention to. But here's the basics of how it works, and these will definitely help you out when you start working on getting your Juniper Networks certified internet specialist, or the JNCIS-ENT certification. So anyway, thanks for listening, and I hope this was helpful to you. Take care.